Welcome to the next scale model. We're dealing with 1 to a quadrillion. And we call this Peta because it comes from Greek meaning 5, so 1,000 to the power 5. And previously we talked about the difficulty of showing the scale of the stars. So at this scale model, we can finally get a feeling for how far stars are separated. Now, if you remember from the 1 to a trillion, we are showing the orbit of Neptune had a diameter of about 9 meters. And now at 1 to a quadrillion, this is what it looks like. So this is the orbit of Neptune. Kind of shows you the planets of our solar system. The actual sun and all the planets revolving around it and everything, they're all microscopic. You don't see anything. You just see from this distance, at this scale model, you would see a bright glowing piece of dust. It's too small to see any detail. And so now the question is, well, how far away is the next star other than the sun, right? At this scale, a light year is about 10 meters. And if we go to the next closest star, Alpha Centauri, it's about 4.2 or 4.3 light years away. It's about 41 meters. So it's that second tripod right over there. Not only are stars really far away, but until recently, relatively recently, we didn't know what these things were. In the ancient days, people thought the stars were just points of light stuck on a celestial sphere that rotated around the Earth. And there were a few people who did suggest otherwise. Democritus, in around 400 BC, it was a Greek philosopher who suggested stars are really suns, but just really far away. And that was speculation. And Giordano Bruno, again, in around 1500s, he suggested the same, and he even said that, well, stars, which are suns, probably have their own solar systems as well, and today we know that's the case. Back then, it was very heretical to mention that. And believe it or not, it was only in recently, 1838, where we took our first measurements of the distance to the stars. We had an idea already that they were far away, because based on the brightness of stars, and assuming that they're roughly equivalent to the sun, and you would have to put them very, very far away for them to be that dim. In 1838, Friedrich Bessel took the first measurements to the closest stars. And I've set something up here just to simulate the technique that he used. It's a parallax method. Assume the sun is here, and assume that tripod is a close star. And so in this case, we'll say that's Alpha Centauri, which is about 4.2 light years away. And behind is the distant background. There's the Lighthouse. It's about 400 light years away equivalent. And so how would you measure a distance to the closest star? Well, you certainly know that the orbit of the Earth moves around the sun, and you can take an image of the star when the Earth is on one side of the orbit, and as it comes around to the other side, you've changed your position a little bit. And that change in position shows up as a slight shift of the foreground against the background. And that's the technique they used in 1838 to come up with the first measurement. And I'm going to try to do something similar and see if I can get a slight change in the foreground of the tripod that I set up over there. I'm going to cheat a little bit. Instead of using an equivalent distance of the Earth's orbit, I'm going to use equivalent distance of Neptune's orbit. Make life a lot easier. So that is the size of Neptune's orbit. At the scale model, that's 9 millimeters. And so what I will do is shift my left to right slider here by 9 millimeters and see if I can get any parallax at something that's 40 meters away. In order to get a sense of the Milky Way, which is much, much larger, which is 100,000 light years across, we need to go to the next level up, to the next scale model, 1 to a quintillion. The lighthouse we're looking at is 440 light years away at the true scale, which is still a tiny fraction compared to the Milky Way. And the Milky Way is a tiny fraction compared to going further out. So we've again run out of space, and we have to go to the next level, which is 1,000 times more. I'll see you in the next one.